You can take it away, Ben.
Yeah. Okay. Very good. Welcome everyone for joining us. We'll be hosting a webinar on data and analytics. And by we, I mean focus leads is Luna Verhasselt from Flexo and myself, Ben de Wind from Expertum. We're the focus leads for data analytics within Sapiens. We also have Niels Christians and LP de Bot from Sapiens who are supporting us. And today we'll be talking about the Business Data Cloud and SAP Datasphere. We have some wonderful speakers here. And let me first give you an overview on the house rules for this webinar. So the session will be held in English. If you have any questions, feel free to post them in the chat. And at the end of the session, we'll pick them up in a Q&A session. So the speakers are not interrupted during their presentation. As you might have noticed, the webinar is also recorded, and the slides and the recording will be shared afterwards with all the participants. And if you would have any questions or you'd like to follow up something, you want to speak maybe with one of the speakers or whatever, you can always contact Sapiens via the email address info@sapiens.be. Or if you would have any topics or ideas that you want to see discussed in the next webinar or another session of Sapiens, feel free to post us your suggestions or issues you're struggling with or questions you have for that you don't find the answers or questions for SAP. We can always try to find the answer together with you. But then we'll move over to the agenda. So first we'll have Simon van der Lanotte and Silke Vergote from Delaware, who will present us the generic AI in combination with Business Data Cloud and Databricks. They will show you how you can push your data to the next level. And in the next presentation, we have Rogier Schipper from Expertum in the Netherlands, who will give us the customer case of Datasphere being used at Ausnutria for collecting and preparing your data for reporting. And afterwards, as mentioned, we have the Q&A session where we can answer all your questions. So it's my pleasure to present to you Simon and Silke, who will tell you a bit more about Business Data Cloud and Databricks and generic AI. The floor is yours.
Oh. All right. Thank you. Normally we should be hearable and the screen should also be visible. So maybe short introduction. Who am I? My name is Simon van der Lanotte. I'm currently solution lead SAP Business Data and AI at Delaware. I came actually from an accountancy background, but quickly got interested in reporting because that's a big thing of accountants, numbers. And yeah, rolled into the SAP world and had so much fun that I never left. So went from BW to Datasphere to now Business Data Cloud.
So I am Silke Vergote and I'm an SAP Data and AI consultant and also an AI accelerator at Delaware. As an AI accelerator, I make sure that everybody in my team has access and knowledge to adopt AI in their daily usage. Yeah.
All right. So that's who we are. Yeah. You probably already seen the doom numbers, as I like to call them. What is it? 65% of organizations are stuck in AI pilot, blah, blah, blah. I mean, I don't like to focus on the negative, so I'm going to move away from those numbers. I like to look at the positive side of things, like what do we see that successful AI initiatives do right? And I think we see three things there. I think the first thing, and it's an obvious one, but it's actually, yeah, important to note down because a lot of mistakes get made here. Make sure you get the right data and the right models. So many mistakes get made here. Yeah, too much data, too little data, not the right data, the wrong model being used for the wrong use case, using a very expensive model for a cheap use case. And that brings me to my second one, balancing quality and cost. That's also a really important one. You also always need to be aware of the business case and then the cost you're putting against that. If you have a crazy custom development with a very expensive model that consumes a lot of energy tokens from, for example, SAP Databricks, is that worth it if the business case is that it saves maybe 10 euros a week? And then secondly, make sure, even though you're experimenting, even though you're doing a proof of concept, I think that's perfectly fine. That's typically a good way to start with AI. But make sure you already think about how are we going to scale this in our organization. If we have to move this to production, did we think about security? Did we think about access controls? Did we think about governance? Did we think about moving models? Because moving a model from development to production is sometimes not that easy as people think. So always keep that in mind when you're experimenting, like how should we scale this? And maybe briefly for the people who are unaware, but I'm going to go really briefly about this. What is SAP Business Data Cloud? So SAP Business Data Cloud, I call it evolution, not revolution. It's a new offering from SAP launched last year. It's a free software as a service, cloud agnostic, so you can host it on whatever cloud provider you want. And it actually is a combination of a lot of existing products, along with a lot of new features. So we have a basis of essentially more of a data lake architecture that is being brought forward, where we have an object store with data products. Data products, imagine them as like kind of preset objects that contain all your information that you want in a certain business object. So for example, a material can be a data product, a sales document can be a data product. You can have both SAP data products, which you can install if you have the right system, or you can create your own custom data products. And then you can connect to SAP apps, to non-SAP apps, but what's the most critical, what's behind the hood of Business Data Cloud, you have a lot of tools you probably already heard of. You have, for example, SAP Datasphere, which is the latest cloud data warehouse of SAP. You have SAP Databricks, which is a new one that's out of the partnership with Databricks. They created a specific version of Databricks embedded in Business Data Cloud. And then you also have SAP Analytics Cloud, which should be known. And then you also have a cloud version of BW, which is called BW Private Cloud Edition. So that's a bit in a nutshell what Business Data Cloud is, just to get everyone on the same page. Very brief explanation, missing a lot of details, but that's not the purpose of this session. What is this beast SAP Databricks? So SAP Databricks is a specific version of Databricks. Databricks is a standalone data intelligence platform, as they call it themselves. It's technically kind of a competitor of Business Data Cloud, but in the partnership, they close ranks and they enabled a version of Databricks within Business Data Cloud. So any customer that is on a Business Data Cloud contract can activate SAP Databricks out of the box. It's also software as a service with credits. So you can allocate some credits from your Business Data Cloud contract and just allocate it on SAP Databricks. SAP Databricks is also pay as you use, so you can start very quickly. That's a bit the thing we want to talk about today. You could start with a small experiment tomorrow and just activate a couple of credits, run a model, and see where you go. You might say, Simon, what do we use SAP Databricks for? What is the purpose? SAP Databricks has 3 specific purposes, and these are slides from SAP Databricks themselves. So I'm not inventing things. One, they talk about domain-specific AI built upon SAP and external data. We're talking then about custom GenAI solutions, and we'll be showing them later. Silke will be showing what we mean by that, but you can quickly start an LLM model and have some use cases around your data that is in Business Data Cloud, in those data products, and run a large language model, run some GenAI on that. Very easily activated and done. Second use case is the traditional AI ML. You want to go with a typical regression analysis or whatever, fraud detection, customer churn prediction, forecasting, predictive maintenance, like all those kind of use cases that actually already existed a long time before the AI hype, calling it like that. That's also what this platform is specialized in. So typical data science. And then lastly, Databricks, SAP Databricks is also very good in accessing strange sources. So if you have strange data sources with unstructured data, or maybe it's a very difficult API that needs like complex loop logic to get your data out of it, there's always in an organization these complex data sources that are not within a normal way of working, like an SAP system, like that's usually very structured. Those unstructured sources are a really good use case for SAP Databricks as well. Now, what do we mean when we're talking about GenAI? Because it's very broad. Just want to give you 4 examples of what we use this for. Firstly, information extraction, like we call it. You have unstructured text somewhere, maybe in your SAP system, even people can fill in a free text or something like that. Or maybe there's a CRM tool where customers can give complaints or something like that, and you want to analyze the sentiment of that complaint. That's something that a GenAI is perfect in. It can really well assess a sentence, maybe bring it a bit more structure, maybe analyze a sentiment out of it, maybe give it a label. This was a good review, this was a bad review. You can build your own custom LLM agents. So you can build your own agents that perform specific tasks for you based on input. What we're going to be showing today is kind of a knowledge assistant where we'll be asking, often this is called talk to your data. I think in the data, in like the world of data, this is the biggest use case for GenAI. Talk to your data, ask a question like, what is my sales doing this month? Can you find me outliers in my data? Like what's my margin? Why am I losing money, for example? And then of course you can always do multi-agents as well, which is essentially the same as your custom agents, just working on different tasks. All right, but yeah, there we go. So I'll pass the word now to my colleague Silke, because I've talked a bit about the general overview. Like we're talking about GenAI, we're talking about traditional data science in Business Data Cloud. Now let's see it in practice. How does it work, and how can you get started yourself if you have this system, or if you want this system?
So thank you, Simon. So as we see here, we have a general architecture of the landscape, where Simon explained that we can create some data products, and then via zero copy share, delta share, we can read them into SAP Databricks. And in SAP Databricks, we can do some experimentation or data science. We can do some modeling, feature engineering, machine learning, orchestration, and also monitoring of those machine learning models. And then afterwards, the results that were created in SAP Databricks, they can once again be stored in a data product, which can then be shared again to Datasphere and can then be used in your front-end tools. Now for today, we prepared a twofold of demos. We have a machine learning demo. Machine learning, those are the predictive models trained on the historical SAP data that learns patterns to forecast future outcomes. Some examples could be to do some churn prediction based on your CRM data, or some fraud detection based on finance data, or some demand forecasting on your sales documents. And on the other hand, we have generative AI. Those are language models that generate answers, summaries, or even codes where no training is required, and they work immediately on your data, where you can have some natural language querying, automated narrative reporting, or even document and contract analysis. For the first demo, we prepared a machine learning case where we created a data product in SAP Datasphere on the sales documents via zero copy share. We shared it to Databricks where we have the pre-processed data. And afterwards, you can even add some external data. For example, if an ice cream seller would want to forecast the sales, he or she would want to include the weather forecast in this forecasting model, and this can also be done in Databricks. After you have all your data, you can train your model and make some predictions, and then these predictions can then be stored in your data products, which will then be shared via BDC. Now let's take you to the 4 steps in a machine learning case. So the first step is to ingest your data and prepare your data. Afterwards, some exploratory data analysis is performed. And based on that EDA, you can do some feature engineering. And actually, those 3 steps together, they take almost 60 to 80% of your time, and they are actually very, very important to handle with care. And then after you have done your feature engineering and your data preparation, models can be trained and evaluated in order to make some predictions on your SAP data. Now let's go to our demo. This demo is in 4 parts, so the data preparation, the EDA, the feature engineering, and afterwards we have the model training and evaluation. I also prepared them in 4 separate notebooks in Databricks, which we will then run in sequence. All right, so we started with reading in the data into Databricks. Herefore, we had to use the Spark because when data is shared with the Delta share, the data isn't actually stored in a physical table in Databricks. That's why we had to use the Spark table function. Scroll down. As you can see here, we had from the standard CDS view, we had 162 columns. That was a little bit too much to create a machine learning model. That's why we selected some columns to take into account for the model, and those were then stored in a materialized view. Afterwards, we did some exploratory data analysis. As I stated before, this takes up to almost 60 to 80% of the time. So this is a very detailed and big notebook to get some insights into your data and to get to know which columns or which features you should take into account for your data model. I'm not going to go over all the insights we got, but what I wanted to show you is, let's go below. So in here, we created a correlation matrix, which is very important for your machine learning model, because you don't want to take into account correlated features because they would have a big impact on your predictions. So we created a correlation matrix, but a helpful feature here is that you can use Genie. So for example, if you would not know how a correlation matrix works, of which conclusions to take out of this correlation matrix, what we can do is ask Genie to give some recommendations based on this correlation matrix. So let's test this out. now you see that Genie is actually creating some recommendations for us. Accept it. And as you can see here, it states that the tax, for example, tax amount and net amount are highly correlated. So consider dropping tax amount to avoid multicollinearity. And other recommendations. And this is a very helpful feature that shows that you don't need the big technical knowledge to actually create those machine learning models. Yeah, so that was the EDA. And then afterwards, we have the feature engineering, where we take into account which columns we're going to use as predictors. And I've used the insights from Genie. So I dropped those here. I dropped the tax amount because Genie recommended it. And afterwards, I performed some other feature engineering, like extracting useful signals from your data, from your dates, where you can get the month, the day of the week, which can be important for your predictions. I made some categorical features. All right, and afterwards, then I split it up, the data in a train and a test set. So the training set will be used to train your machine learning model, and afterwards your test set will then be used to evaluate that specific model. And the training and testing is done in the last notebook. So we read in the train and test sets. And as you can see here, I made up an experiment where I tested 6 different machine learning models. We have some linear models, like the linear regression, the rich and the lasso. And then we have some ensemble methods with the decision trees, the random forest, and the gradient boosting. I won't go into big details about these models. So what I've done here, so every model in here is trained and tested on the data that we provided. And then I want to go to the results. And in here you can see the results for each model. We're going to use the R-squared, and R-squared means how many percentage of your variation in the data is explained by the model. So the higher your R-squared is, the better. And we can clearly see here that the ensemble methods were better with even a score of 99%. So our gradient boosting would be the best model to take here. And what we also did, so you can log your metrics in here, but you can also use MLflow. And in MLflow, you can do some experiment tracking. And in there, you can also log your best model. So this will be the gradient boosting. Let me go to the MLflow. In here, you see that I've made an experiment called sales net amount prediction, where I stored all the results of my experiment. Voila, and here you can see your R-squared, and you can actually compare your experiments, and this also is important for your traceability of all your models.
Maybe shortly to add to that, I think that's also a nice thing. You used to need to be really a specialist in knowing what all these individual models did, but now you can more easily navigate, let SAP Databricks just run all the models and see which one comes out on top and use that one. So that's also a nice feature, I think.
Yes, indeed. So, and afterwards, now I've shown you that we trained a couple of models, and we saw that the gradient boosting was the best performing model. However, as your data changes, also the insights and your model should change to take into account that data drift. So that data drift means that the circumstances, the predictions change the more data you get, or if some circumstances change. So here there are a couple of options when to retrain your model. You could opt to retrain your model after a certain period of time. So, for example, every 2 weeks, we're going to retrain the model to make it more accurate because there was more data included. You could also opt to retrain your model when a certain evaluation metrics is below a certain threshold. As you saw, we had an R squared of 99%, but you can also put in a rule that the model needs to be retrained if the R squared is below 95%. Or you could even retrain your model after new data or after an X amount of records is registered in your data. However, you need to take into account, would you opt for an automatic deployment of your model after a certain time, or when your evaluation metrics is below a certain threshold, or you could lock that retrained model in MLflow and only deploy it to production after human approval. All right, and then the second demo we want to show you is the generative AI case. Here we will use the same Databricks product. So again, on our sales documents, where via zero copy share, we read the data into Databricks, and then we used a model that is stored in Databricks, so the Claude Haiku model, that then generates a text answer based on a user input of a human language. In this demo, we did not include it, but you could then write that output from your generative AI model back to Datasphere or your front-end tool. You could, for example, ask the generative AI model to write you a summary of your data, and that summary can then be written back to Datasphere, be it in a table form to use in your reporting. So let's go to Databricks again. All right, so my generative AI demo is in a single notebook. What happens here is that we connect to an AI model that lives inside SAP Databricks. This means that your data never leaves the environment or your landscape. It stays inside this landscape. Afterwards, we retrieve the metadata, so the structure of the table in the data product. We create a general function for asking an AI question. So we create a prompt and then we retrieve the answer of the GenAI model. Then we created a function to actually translate the question you pose to it in human language. We're going to translate it into a SQL statement in order to give back the answer. And then we have another function that actually generates then the text answer based on the SQL results. And actually here is our main statement or our main prompt that combines all the functions we coded above. Right. As you can see here, I already asked it a question in here, so you can enter what are the 5 orders with the highest total based on your sales documents table. Let's run it again. I had some example questions, so maybe let's test and ask it a new question with what is the order with the highest amount. And let's wait for its results.
Maybe briefly, while we're waiting, to explain why are we splitting up all those tasks. I think that's typically what you see now in acting with GenAI. You do not write one big prompt with everything in it. You split up the functionalities. Because if you have one big prompt where it's everything, you notice there's much more risk of having hallucinations or having like only taking one assessment and forgetting about the other one. But if you split it up into really neat tasks, it responds really well.
The model actually answered our question and stated that the result, the sales document with the highest amount is this one. What we also do, you can track your models in experiments and ML flow from your machine learning cases, but you can also do that from your GenAI cases. And what's nice here is an experiment I did an hour ago. You can actually see the generated SQL statement that was created based on the question in human language. So here we see the SQL statement where we asked
probably highest sales document.
Yeah, what are the 5 orders, the highest total in human language, and you can see here the SQL statements that is linked to it.
And this is nice towards explainable AI because you always get a trace of what was behind the black box.
Yes. So those were the 2 demos we wanted to show you, and as the main key takeaways, we wanted to emphasize that there's a seamless data flow from Datasphere through BDC with that zero copy delta share, and your AI or your AI models run inside SAP Databricks, so the data never leaves the environment, which is a good thing in terms of security. And as thirdly, there is no need to have a deep technical knowledge required, as I showed before, for example, that Gene can answer your questions regarding those correlation matrix or regarding how to make up codes to code specific machine learning models.
And SAP Databricks also gives a lot of help as well. Like you saw some of the functions in the notebook and they might seem complex, but SAP Databricks has a lot of templates on how should you write this kind of GenAI function, how should you write a connection to Claude to make sure you can use that model and stuff. They have a lot of stuff online available and code copy that you can do to get started.
Yes.
Of course, as an end user, if like a business user would interact on that, you would then build an app on top of this and make sure that the business user never interacts with a notebook. I mean, I don't think the typical finance person or controller is interested to go in a notebook and code. You would then build an app on top where the user can ask their question in there, and then the model does its thing behind the screen. But yeah, that's what we wanted to present today. So hope it gave some inspiration on what SAP Databricks is. I think that's a very important. What is it? Well, what kind of beast is it? What can it do? And I hope we also inspired, like technically by proving with a demo what it can easily set up. Like these were not big blocks of code. These were very simple blocks of code that can get you started on these kind of use cases. And started on these kind of experiments. And the good thing is, because you are working in a controlled environment, it's very easy to bring this to production later because security is already thought of. There's already CI/CD that you can easily transport your code to production. So you can experiment with the freedom of knowing that you can later put it into production. So hope we inspired there. And yeah, thank you very much. And thanks for the demo.
Thank you.
Okay, then I think we can now move to the second session of this webinar. and that will be presented by Rogier Schipper about how Datasphere helped Ausnutria to mature their data warehousing strategy. The floor is yours, Rogier.
Yes, thank you. Yes, let me share my screen and open this one up. Yes. Here we go. Yeah. So first of all, thanks for having me here as a northern neighbor of yours. Been discussing this with Ben already for some time that it would be nice to share something about Datasphere. I think it was originally planned for somewhere last year, but happy to do it now. And indeed, a lot has changed, as we've just seen by the presentation of our other friends, Silke and Simon. So there's a long way that SAP has gone in the meantime since we started off this path with Ausnutria. But I like to take you along on that journey. So what did we do there to basically set up a data warehouse environment in the cloud? And I think if you want to use, for example, SAP Databricks, also that comes with a lot of good data. And as you just heard, one of the sources there is, of course, the data that you have in Datasphere. So I think it's a nice bridge there. Shortly about myself, I'm working for Expertum in the Netherlands now since almost 3 years. Before that, I've been working for a long time in Philips and a spin-off of Philips, which is called Versuni, which is domestic appliances. And a lot of those things that I did were in the BI area with various tools, but always really focused and interested by the SAP solutions. And especially since I joined Expertum, have been investing a lot of time in that with BDC, SAP Datasphere, and SAP Analytics Cloud in the recent years. Shortly about Ausnutria, it's a company that you might not know. It is a company located in the Netherlands, and what do they do? They basically produce infant milk. Based on goat milk mainly, but also on cow milk for basically feeding the babies if it cannot be done by mother milk or to add to it. And that was really booming in recent years. Quality, of course, is that's one aspect. Quality, of course, is very important there. So everything that goes through the food chain has to be of a good quality, and that's also where we will start off the process of setting up Datasphere at Ausnutria, which I will come back to later. But basically, as I said, it's really been booming in recent years. You might recall that a couple of years ago there was a shortage of these type of milk powders worldwide, and then especially in China. Which meant a large boost of Ausnutria, especially in that area. So it's still one of the main markets there that they have, and also recently you see here in the area they've been basically taken over, or an investment company from China stepped in to take over a large part of the business there. Main office is still in the Netherlands, but you see there is a strong stronghold also in Asia at the moment. 9 production sites worldwide, quite a number of people working there. So it's a relatively large organization that grew a lot since I think 2020. In the Netherlands, we have, I should say, I'm not working there anymore, but they have a couple of locations. Basically, what they do in these locations, to give you a small glimpse of what it is that they do, they get in the goat milk and the cow milk in what they call wet blend facilities, where they basically create base powder out of it. That's mainly happening in the factories in Heerenveen and Zwolle. And after that, they turn it into basically the powder that they sell in the market. So they add all kinds of stuff to it, vitamins, those kind of things, to be able to sell it and to have the right mix there. And that is also done in Heerenveen, but also in Leeuwarden. And they're working very closely together with the Wageningen University in the Netherlands for R&D related activities. Main office is in Zwolle. I think that's basically it. So you have a bit of an idea about the company that we are going to talk about. Since this is an IT story, it's always good to know where they are heading from an IT perspective. They are running SAP ECC still. They have an SAP integration suite system running. Basically they want to have a reliable IT environment. As I said, quality is the core of their business. It needs to come back everywhere. They need to be able to trace basically the raw milk from coming in until the powder that's being sold. Also in case of things going wrong somewhere in the process, that you are able to identify batches at a really detailed level to take action if needed. So reliable and secure, I think that are the main topics there, with a high level of quality. Until a couple of years ago, business intelligence at Ausnutria was actually non-existent. So they were having Excel sheets and doing all kinds of manual downloads from the SAP environment, and basically creating the insights out of there. Well, the CIO stepped in and said, well, I think we need to change it. We need to basically more mature our game when it comes to reporting and insights. So they did an investigation. They went to the business and said, okay, if we are now going to talk about an BI environment, what is it that you feel is important? So they gathered some reporting requirements, which are listed here on the left-hand side. And that goes from validated reports to near real-time data, good performance, abilities to reuse your hierarchies that you have in SAP, for example, but also different types of visualizations. And next to that, they also wanted to be able to integrate the data that they got from SAP with other source systems as well. And then ideally on an automated way without having to constantly download and upload data to various systems to get the insights that they need. And from a security perspective, we needed to have an authorization model in place there as well. But with that in mind, they started the venture, and they started the adventure in 2023. Where basically the requirements gathering was done. And initially the idea was to just put SAP Analytics Cloud against the ECC environment. So not a BI landscape against it, and to see if they could mimic a report called trend analysis. And the trend analysis is doing a measurement of all the ingredients that they have in their products, and to see whether they are within the thresholds that are required. You should not have too much vitamin in your product, but also not too little. And so that's really something that they are constantly measuring things about. And that was also something that they were currently doing in Excel, but it was time consuming, and they were always lacking there for a month, because they could only do the download and the upload once a month due to the high amounts of data that they were getting into the environment. So they started off with a POC on SAP Analytics Cloud, which is very simple. So if you just look at the landscape at that moment, just take the data from ECC with a direct connect without a data warehouse involved. Well, actually, that was not a very good solution. They already figured out quite fast, because performance-wise, it was not delivering the things that they would need. So if you wanted to work with this, you needed to create very specific views with a lot of filtering on highly aggregated data, and that did not give them the option, for example, to zoom into the real inspection lot level to check for any outliers. So, and they said, yeah, we need something else. And they came to us again and said, yeah, what is another option, another alternative? And then at that moment, we had already quite some experience with SAP Datasphere, which was in the market, I think, by then for a year or 3. And we said, let's put Datasphere in between, because you can easily model there your data, and you should overcome the performance issues that you were seeing in the initial part. Same use case, trend analysis, and we set up the landscape as follows. Next to their production environment, they also have a quality environment. We connected both with a cloud connector to Datasphere. So it's ECC on HANA. So we had a HANA connector there. We were in real time replicating the data from the HANA database into Datasphere via change data capture model. There were some Excels that we needed to load. That was still a manual effort. And we set up the space concept, and this is very simplified, but we basically had a reporting space where we create the analytic model, and that one was exposed to SAP Analytics Cloud. And actually those results were a lot better. And it was seen as the way forward. There we overcame the issues that we saw in the performance area. People were able to do the drill down in SAC as they saw. And from there on, we really started to what we called at that time the explore phase. So we wanted to look at other areas than just the quality management part for the trend analysis. So we looked into finance reports. We looked into self-service options. We went into a data exchange model because, as I said, they were taken over by a Chinese investor, and the mother company, they wanted to have insights themselves as well. So we needed to bring data to their BI environment, which was a non-SAP environment. It was based on, I think, Chinese custom-made tooling. And we needed to create a connect to Power BI reports, because in some cases, as you might be aware, people in the business like to have Power BI over SAC because of the ease of use and the Microsoft stack that it easily integrates with. So that was not something that was uncommon for Ausnutria as well. So we started up that track, and that was basically during the year 2024, where we added those additional use cases, and we added the export mechanism to the China digital data platform, as it is called, which was a expansion of the landscape. Next to the reporting space, we created additional reporting spaces, basically reporting spaces based on the functional area. So we had one on the quality assurance side, but finance, of course, required another space also for authorization perspective, and that you could easily distinguish the two. We had what we call a China space, which we put the data in that was required for the external system. That data could be connected via JDBC, and I am aware that it is officially not something that SAP is currently allowing, but in this case it was the only option to do it like that, unless we were allowing them to do an OData connect to the data, but that was actually also not performing. For Power BI, we had a similar connection, so also their data needed to be moved to Power BI. We used ODBC for that to actually load the data into Power BI and do the visualizations there. And we had the SAC Excel add-in for more self-service like reporting, so it allows people to easily work in Excel on the data that is in the Datasphere environment in your models, and to do your drill down and your analysis there. And that was for the more tech-savvy Excel people in the business. So this was basically what we call BI Landscape 1 or 1.0. We felt we were mature at that time to deliver various business reports to be able to send data out of the environment to fulfill the needs of the China mother company, and also to have the connection to the source systems in an automated way. Basically loading all the data as much as possible in real time, and where not, we were extracting data overnight. Then the next phase, actually, if you are beyond the explore phase, you really go into the govern phase. So we needed to set up the organization around the data warehouse. Decision structures on when do you do what, and when do you, for example, bring data into Power BI, when do you send data over, what type of data do you send over to an external system, how do you ensure your authorization concept. We needed to set up a support organization, and of course train and do some knowledge sharing within the organization. Up until now, it's been really a expertum party when it came to the development of the models and the stories. But as of now, there were also people from Ausnutria themselves involved, who were in the end going to take over those reports and maintaining those, and also learning on how to set up analytic models and do the extract of the data. And of course, standardization is also something that we needed to have, and we needed to have some key principles when it came to setting up the environment. That's something that I will zoom in a bit. Data structures and data models, they needed to be defined and also reused. Reusability is one of those things that we were looking into. And also the reporting format. So what type of templates do you use? We were trying to use IBCS standards as much as possible when it came to setting up the reports, because they were easily understandable for the business users. And we needed to set up some monitoring, which is also something that I will come back to in one of the following slides. And this is basically what we did last year. There were a couple of projects started replacing BO functionality. They had some BO reports. I said they didn't have a real BI strategy, but they had some BO reports. They needed to be replaced. The export mechanism needed to be extended. And of course, from the business, there were new requirements regarding the creation of additional reports for various business streams. Now, then zooming in on those key principles, which are essential if you want to have a bit of a mature data warehouse, because if you do not know Datasphere, basically when you get it, it's an empty box. It doesn't have anything. You can activate some business content, but I would not really recommend it. Maybe some of you are aware of business content in the old BW environments. That could be a handy starting point. In this case, it would not, because they're all deployed in sub-specific spaces. You could not change them. You could be able to copy them, but basically it's better to just start from scratch. But if you do so, you need to have some guidelines and some rules around it to be sure that in the end you find your way back, and it's easy to find the relevant objects back, and to have some structure in the various layers in your data warehouse, of course. So we were looking into three areas: reliability, availability, and stability. So reliable data, so the data needed to be validated. There need to be one version of the truth. Models need to be able to be reused as much as possible. So extract once and use many, for example. I said the authorization concept needs to be in place, and things need to be automated, so with as less manual intervention as possible. Availability. So if people needed the data, they needed to have it. So it needs to be, again, automatic, but also in time. And for those things that were not real time, we needed to make sure that at least people were aware that at what type of data they were looking at, when was it loaded, when was it, for example, persisted. And yeah, that needs to be done at a minimum on a daily level, if not in real time. And also, notification in case of issues. So if you set up some loads, you need to get a information message in the case that loads are failing or that you have performance issues. Now, performance itself is also important because if things are not going as fast as they should be, people have to wait for 10 seconds before they get a reply on a query that they make. Then of course they will also lose focus and go searching for other solutions than the ones that have been built for them. And it was very important to have both an aggregated level, so it's with quickly accessible data and insights, as well as the option to go to a more detailed data set and to have basically all the underlying data available as well in your reports, or at least in some of the reports. And stability. So we are extracting from the SAP ECC system, of course. We do not want to have an impact on that. What you saw, for example, when we were still using the SAC directly on ECC, if you were running a heavy query there on SAC, it was impacting the ECC performance. And the same happened when people were still doing downloads, manual downloads, and feeding them into Excel. Also those manual downloads were actually heavily impacting the ECC environment because it was a lot of data that was exported, and we cannot have that in a running production system, of course. So that's why we said we need to decouple the reporting from the source, and that is where, of course, the data warehouse itself came in. And in the end, also their stability is about performance, but also about end user experience. So people need, in the end, they need to be able to trust the data that they are looking into. Zooming a bit more in on those three key principles. If you talk about reliability and what did we do there, I already draw a bit of the pictures on spaces. So if you work with Datasphere, you are able to set up spaces. Basically, from a space, you can make a connection to a source system. What we decided to do is create one space that has the connection to the source systems. And that is called, in our case, the central space. You can divide their things in various folders. We've chosen to set up a folder structure based on functionality, but you could also do it in a different way. For example, with an inbound layer, a view layer on top of that, and then your facts and dimensions, and then in the end your analytic models. Basically, the only thing that we do not do in the central space are those analytic models. So that is where SAC is connecting to. That are your replacement of your multi-providers when you are looking into BW. That are your analytic models, and we've created spaces reflecting those functional folders that you see in the central space to separate the functionality in spaces. Next to those two concepts, so reporting space and the central space, or reporting spaces, we also had the extraction space, or as I called it in the other picture, the China space, and so a space specifically to put data that can be extracted via that JDBC connection. So we only put limited data in there, only the relevant data that is required to be extracted to prevent a lot of data is going over the line, and useless data is going to be sent over to China. And we have a governance space, and in the governance space, you set up the monitoring things from SAP. So regarding jobs that are running, but you could also set up your in-data authorization concept there to separate that from your central space. Very important point, I've marked it on the left-hand side, is naming convention. So as I said, Nothing comes automatically there, so also not naming. So it's easy if you do not have a proper naming convention. It's easy to lose oversight of what you have been doing. So it's very good to have a standard there. Then on the availability, as I said, we need to make sure that the data is available. So some data is definitely available in real time because we follow that change data capture part. Unfortunately, that doesn't go for all the data. So in some cases, if you have a table that doesn't have a unique key, you are forced to create a kind of pseudo delta on that that you run for, well, in our case, overnight. And in some cases, we needed to do a persistency of the fact views that we have because there was so much business logic in that, yeah, if you just ran the view over the raw data in the inbound layer, it would take too long. So in some cases, we needed to persist those facts, and we were running those, basically every hour to have the almost latest and greatest data available there. But apart from that layer, so apart from the inbound layer and some of those fact views, all the other views that we created, they are non-persistent. So you do not need to store your data in every layer that you create. And also the analytic model is just a virtual layer over your fact table and your dimensions that are associated to that. We did create a custom made monitoring tool. You see a little bit of an example at the bottom of the screen, because out of the box, at that moment, SAP was not really delivering a lot of insights in your jobs when they failed. Yeah, there is a way to look into failed jobs or into your jobs into Datasphere. But it's not giving you an option to easily filter on that or to get a good oversight over time on how your jobs are performing. So we've created one ourselves, and you can do that on the data that SAP is providing to you in that governance space. So it's just a flag that you said, generate me the data on that monitoring on those jobs that are running, and that allows you to simply create your own SAC report on top of that, and that's basically what we've done here. Then the last one, stability in reporting. So performance, we said response time should definitely be below 10 seconds, ideally below 4. But in some cases you really need to have people are really asking a lot of data and going to detailed levels of data to be shown on the reports. Then they may expect to have a little bit more than 4 seconds of waiting time. But just if you navigate or you click through to another screen, everything should basically pop up within a couple of seconds. No source system impact. Obviously not, because we are either running loads overnight or we are following the change data capture mechanism. Reusability of facts and dimensions. So it's really key to set up proper fact views to prevent that you have, 4 or 5 fact views that are talking about your sales orders. So it's better to have that in one place. And if you have your various analytic models on top of those fact views, and then you can make the distinguish there. You maybe do not need all the fields of your fact view in all your analytic models. And you can still apply some business logic there in calculated and restricted key figures as well. From a reporting perspective, IBCS standards, as I said, use those as much as possible. And we always start with the aggregated data and then allow people to drill down. So as an example here for the trend analysis report that we created, you can see how many faulty measurements there were in the various material categories. But if you then drill down on one specific one, you really see the measures over time and see whether or not they are still within the thresholds, and you can also easily identify some outliers there. When it comes to data sharing, I think that's important to mention as well. So As I said, ODBC, JDBC. Officially, SAP is now hinting to the delta share mechanism, for example, with the zero copy that was just mentioned in the previous presentation. You could do that to bring your data, for example, to Databricks and in the future to Snowflake. The system that our Chinese colleagues were using was not one of those systems, so we needed to come up with another solution. That also the outbound premium option, where you can export data to Azure, for example, or to Google, was also not an option for us. So that's why we needed to basically go with the ODBC JDBC solution, because it's the only option to be able to connect to that external system. As I said, it's a controlled way, so we have specific spaces for external target systems to connect to. That means you can also, on those spaces, you can also limit the CPU and the memory consumption in those spaces to prevent that, for example, an external system is continuously pulling data out and your own users on your own system that are running SAC reports against your reporting spaces are impacted by that. And so we always give a lower priority to the extraction than we give to the users who are running reports against our data. And it's a pull mechanism, so people, so the data can be pulled on request, but we need to give some time windows and restrictions. So ideally we have those pulls happening overnight, but you are not fully in control there. It would be better to push the data, but we could not find a proper mechanism for that at the moment. Then there was basically one last step that we did not cover, and that was something that happened actually this year, and it was setting up a QA system and moving to Business Data Cloud. So as I said, we had Datasphere and we had SAC. They were still running that on separate licenses on the BTP platform. What we did is, as of January 1st, we integrated that into a BDC contract for them. So they have now BDC, and they can basically consume the credits up to their own needs. So that's the good model. Because you can switch, for example, between SAC licenses and the amount of storage or CPU in your production Datasphere environment or your QA environment, and you can exchange those credits easily there. And a quality environment, they did not have a quality environment, but with the maturity of the environment, it did need a QA system as well, because we could not have that a change on the Datasphere environment, which potentially was causing errors, was directly impacting business users. So that's why we now also have the QA environment there. And as said, the BDC environment on top of it. And it should actually also incorporate SAP Analytics Cloud, which it does not in this picture, but also SAP Analytics Cloud is in BDC here. With that, I think I want to share some lessons learned there of this journey of 3 years. Starting small is, I think, really something that is important if you are able to do so. So in this case, there was a company that did not have a BI environment at all. So we were able to start off small, to start with a proof of concept. But even if you have an existing environment, like for example, a BW environment, and you want to see how and if you can migrate to SAP Datasphere, then also that is typically something you could do with a proof of concept. Identify some use cases that are relevant for you, identify some proof points. What do you want the system to do? And how do you measure the success of such a proof of concept? And then I think it's really worth of doing it in that way, instead of doing a direct full big bang blown cut over from one environment to the other. Organizing the Datasphere system upfront with naming convention, with spaces, with development guidelines. to prevent that it's becoming a mess, because it can, as I said, very quickly become a mess. Performance is something that is key. So initially when we started and we were listening to SAP, they said, well, you do not need to replicate anything. You can just create a remote table connection to your SAP source system, in this case our ECC system, and you can just query directly on that. And yes, theoretically you can, but you do not decouple then your reporting environment from your source system. And you could theoretically create everything in a view on top, but you already quickly see that if you are doing some complex joins or business calculations, that the performance is not good, and in that case it's also directly impacting your source system. So yes, it is good to persist in some cases. So in our case, always the inbound layer, and in some cases the fact layer. Involve the business for self-service capabilities. We hear a lot of times that SAC is perceived by the business as less user-friendly than, for example, Power BI. And yes, maybe that is true, but I do believe that if you involve them on from the beginning on, that they are able to also do their own navigations and self-service, fulfill their self-service needs in SAC. So you have the SAC Excel plugin, for example, that you could use. It is not yet that sophisticated as analysis for Office, but it can cover a lot of needs to a large extent. And also, if you have the data analyzer in SAP Analytics Cloud, it can definitely help people already in doing their basic ad hoc analysis. Then if you want to have an extraction architecture, if this is not your only data warehouse that you are creating, and we see that more and more with companies who have another environment next to an SAP data warehouse solution, like for example Databricks, but also Snowflake or MS Fabric. Define how you want that data to get out of your source system and check the impact. And so there are now new ways of doing those integrations, like for example, outbound premium, but also the delta share option that is more and more covering other external systems next to the Databricks one. That are really key things to figure out on how do you want to have that data flowing into external systems. And ensure that your front-end reporting strategy can be met. So as I said, a lot of people still want to work with Power BI, but connecting Power BI directly on Datasphere is not something that is easily done. It requires a lot of rework. So if you really have a Power BI strategy, you should consider maybe indeed going to a non-SAP data warehouse for serving those use cases. But as said, SAC can also cover quite a number of use cases and should not be underestimated, especially not when it also comes to planning functionality, which you can now also seamlessly integrate with Datasphere, of course. And then create an overall architectural data landscape and check your dependencies. So I think this is a bit double on what I already said, but it's really key to have that picture clear in your head, and that it also allows for extension of your data landscape, and what do you do where, and what is, for example, your AI tool of choice. Is it going to be SAP Databricks, or do you have another environment, and what is then the request from data flowing in via Datasphere, for example. So just some points to take away. With that, I've come to the end of my story, and I think I'm just in time, right? So, I open the floor for questions now, I think, Ben, but maybe not only for me, but also for the presentation that was given by Silke and Simon.
Yes, indeed. If there are any questions, you can now ask them. You can either raise your hand or you can put them into the chat, and then the presenters will answer.
Seems
If
that
anyone
everything
wants
was
to
very
unmute.
clear. I had a message from a few people that had to leave because they had to join another meeting. But
Okay. If there are no questions, don't hesitate. You can still reach out to us or to the presenters via their email, or like Ben already said, via the info@sapiens. Then before we end the webinar, let me give you a look or give you an overview of the upcoming events of Sapiens. And the first one is already this Thursday, which is a webinar about AI-driven maintenance with SAP EAM. Then in April, we have a physical event called Code and Connect, where you innovate with SAP BTP. So this will take place at the SAP Benelux office. And then in May, we have several sessions. People Intelligence, SAP Cloud ALM, and the SAP Sapphire 2026 highlights for the Belgian market. Now, from an analytics perspective, I would like to highlight the People Intelligence session, the 7th of May, because also there we will take a look at Business Data Cloud and how the intelligent apps of SAP regarding people intelligence can be useful for your HR reporting. Lastly, I would like to thank the presenters, Simon, Silke, and Rogier, for preparing the content and sharing your projects and experience with us. Like I said, if there are any questions from the people still in the chat, do not hesitate to add them. Another thing, if there are partners right now in the chat, also, if you want to share content in a webinar like this one, do not hesitate to reach out to us, then we can take a look together if the content fits the webinar. And it's a nice opportunity to, of course, share your experience on certain topics. That brings us to the end of the webinar. Again, thank you to the presenters. Thank you for joining, and see you in next time.
thank you very much, everyone, both joining and both presenters, and hopefully indeed until the next time.
Thank you. Have a great day.